This is a 74HC595 8-bit shift register. It has a option serial data in and parallel data out. Parallel, if you see the pin diagram, parallel data from Q0 to Q7, and the serial data out is like this pin Q9. Pin 8 is ground and pin 16 is VCC. According to this pin diagram, I have connected everything. So I have connected this push button switch is for the shift register's clock pulse, is connected to pin 11, and this push button is for storage clock pulse, and this is connected to pin 12. You see here, and master reset is pin 10, and output enable is always connected to the ground, and this is pin 13. This is pin 13. So pin 9, this is pin 9, this is for pin 9 for serial data out or cascading to the another shift register together. It's been using for that. So for now, this is my data input. This is connected to pin 14, serial data in pin 14. And so let's see how this is working. So all these LEDs here for outputting the parallel output, and this small resistor I have connected for protecting this all parallel LEDs. And these resistors makes a push button switch on and off using for, and this capacitor and this resistor is for like debouncing these switches, and these all resistors are using for making a just push button switch, making a clock pulse like 1 or 0. So let's see how this is working. This is my shift register clock pulse, shift clock pulse, the one, pin 11. So this is debounced, and this is my data in, serial data in. This is connected to pin 14. You see, this is connected to pin 14. Pin 15 is for Q0. So according to this pin diagram, I have connected everything as I required. So for now, I'm just displaying how this is working for serial data in and parallel data out. So this is my data 1010, and this is the shift register clock. So, and this is the storage register clock pulse and 3-state output. So it does like storing the data into the storage register and make output for this LEDs. So let's see, currently 0, I'm putting 1 into the shift register, storing plus displaying with this clock pulse. You see, it's already stored into the storage register, plus it displayed whatever the values was in the shift register, and I'm putting another values into the shift registers, 1, and just storage plus output. See, currently 0. I'm putting value 0 into the shift register here, and then this one will do store plus output. Yep, 0 store, 0 already stored in the shift registers and outputting the value 0. So inside the shift register there is 3 sections. One section is for shift registers and another section for storage the data, whatever the value was in the shift register, and the last section for 3-state output. So last 2 section is controlled by this clock pulse, and first one section, shift register section, is controlled by this clock pulse. So again, data value 1, just in the first stage I'm putting into the shift registers, and sending to the output plus storage with this clock. Yep, 0 output, 1 storage plus output, 0 in storage plus output, and you can see everything is shifting to the left, from right to left. That's the nature of this shift register. And there is one pin here, pin 9. This is for serial data output. I will show you just few seconds after. So how this storage register actually working? So like for now I'm making everything 0 in the parallel output, zero. So like 1, this value 1 I'm putting into the shift register. Yep. And 1 0 I'm putting in the shift register, and another 1 I'm putting into the shift register, another 0, like this. So you can see this is the output. Everything I have put previously, the output is like this, and already stored into the shift register, into the storage register. So if I unplug the power and put it back again, because this clock pulse stored into the store register everything, all the value, so it will stored into the shift register even if you unplug the power. So I put it back in the power. You can see the same value was stored in the store register, it just displaying the same thing. And now without using the storage register, you can use the serial output, and at the same time you can store some data into the storage register as well. So for this I'm doing this for serial output. I've used this register for protecting this LED. I'm putting one value in there, shifting left, out, shifting left, out, shifting left, out, out, out. Yeah, you can see the value, this serial data value is the number 7 pin.